This lesson is looking at surface area and volume for a whole bunch of different shapes. I will be asking you to fill this out on your own, so I'm not going to go through all these definitions, but I am going to quickly talk about some of these different shapes. So first of all, we have the rectangular solid, a box shape, if you will, and the special case of a rectangular solid, which is a cube. So a cube really is still a rectangular solid, it just happens to be one where all the lengths of all the sides are equal. So your textbook uses these formulas where they use E for the equal side. Sometimes you see this with S for S cubed for the volume, for instance, for equal sides, but the formula is pretty straightforward here. Length times width times height. If they're all equal, well, that's E times E times E. So that's why we end up with that. Our area, right, we have two length widths because that is our top and our bottom that we can't see. Two width heights, that's our left and our right sides. And our two length heights, that's our front and our back, the way this particular box is drawn. So we could do that as well with these ones, but since they're all equal sides, all those 6 sides end up being E times E. Cylinder, can shape. So the only two dimensions we need there is the radius of our circular bases and the height. And note that these are right cylinders. In other words, the circle meets at a right angle with the sides that make up the bases. So if we look at those, volume is the area of the base, which is a circle, so pi r squared, times the height. And the area is those two circles, so that's our 2 pi r squared. And the distance around, so the 2 pi r is actually the circumference of the circle. So if you cut this open, you end up with a rectangle that makes up the sides, right? If you were to cut a can right open, or even something easier to cut like a toilet paper tube, you could cut it open and lie it flat, you'd be left with a rectangle that would have one side of the rectangle would be the same as the length that goes around the circle, so that's the 2 pi r, and the other side is the height of whatever your cylinder is that you've cut open. So that's the total surface area, but your textbook also talks about the formula for the lateral surface area. So that's this one right here. Lateral surface area is referring to the sides only, not the bases. I'm actually going to move this down if Word will let me. So it doesn't include those circular bases top and bottom, so we drop off that part of the formula. The important thing to note here is pay attention to when you're being asked for the whole thing, when you're just being asked for the sides. So a cone is, we're all familiar with a cone, circular base, and then it meets at a point. So we're looking at right circular cones, so that point that it meets at will make a right angle when we drop down the height to the base. And so it's a very regular type cone, it's not slanted in some way. The length on our side here is our slant height, and the other piece of information we need is a radius, so that makes us have a nice right angle triangle, and sometimes we need to use Pythagoras Theorem to solve some sides there. So a squared plus b squared, right, becomes r squared and h squared, and our c squared is this slant height. The prism, a couple things I would point out here is prisms aren't always given in diagrams so that their base is on the bottom. So this first prism that we have here, the base is the hexagon and it is on the bottom and the top. But the second prism we have shown here, the base is actually the triangle, it's on the front and the back respectively. So be careful with those prisms, they could be twisted in the diagram, so make sure you realize which part is the base. And the base is always going to be perpendicular to the sides that make it up. And in a prism, those sides are all going to be squares. Not squares, rectangles. They might be squares, but they are going to be rectangles. So again, we've got some formulas, a couple things to be aware of. Capital B is talking about the area of the base. Lowercase b, when we talk about base of a triangle, is talking about the side that is the base. So the lowercase b is a length, the capital B is an area. So this might be measured in centimeters, for instance, whereas the capital B would be measured in centimeters squared, if we had something in centimeters. Some other notation here, I think it's all pretty clear. Again, this S is for the lateral surface area, and A is the total surface area, so we add those two bases on. So in many of these questions, we will have to do some additional calculations to either find things like perimeter or area of the base. Be aware that these can have any shape of polygon as a base. Pyramids also can have any shape of a polygon as a base. So we're often familiar with the square base pyramids. Look, when we see the pictures of Egyptian pyramids, they kind of look like these ones. But pyramids do not have to have square bases. So again, our formula is written quite generally with that capital B for base, because it can be any shape. And I just want to show you a few examples. They're on this website here that I've got in those notes. Let me just flip over to that website. So you can see, again, they've got a nice little diagram on this website where they show that slant height and the height. Be careful, because going down the edge of the pyramid is not the same length as going down the middle of a side, which is where we get that slant height from. So here's a triangular pyramid, so its base is a triangle. There's our more familiar square base pyramid, but we can have pyramids that have a base that's a pentagon. We would call it a pentagonal pyramid. We could have an octagon. It would be an octagonal pyramid. Basically any gon that you can say, you can have a pyramid of it. We are going to focus on right pyramids, where the middle of the base is directly below that peak that it gets to. But you could also have oblique pyramids and irregular pyramids. So we're going to focus on the regular right pyramids. So we're going to keep it fairly simple. Back to our notes here. So all I really need to say about pyramids: spheres, balls, I think you guys are kind of familiar with that. Just be aware, be careful with your formulas. So the volume is 4/3 pi r cubed. The area of a sphere, all the sides of the sphere, is 4 pi r squared. If we look at a hemisphere, if we're looking at lateral surface area where we don't count that base, it makes a big difference than if we're looking at area and we do count that base. So lateral surface area is just the area around our sides, and we wouldn't include the circle that's the flat part of the hemisphere. Whereas if we're talking about total surface area, we're also including that circle that's the flat part. So it's actually an extra circle, which is why we end up with 3 pi r squared, because one circle is pi r squared. So when we're looking at these questions, generally speaking, it's a matter of identifying all your variables, seeing if you do need to do some extra calculations, and plugging them into our formulas. So sometimes it's one step, sometimes it's many steps. First question here, we have a volume given to us for a sphere, so right on our sphere diagram, that works. And we're asked for the radius. So we can plug in a volume, but we want to know radius, so we need to rearrange this for radius. So our first step is the 3/4. Let's get actually the 3/4 pi. So if I want to get the r alone, I'm going to multiply by 3 on both sides, divide by 4 on both sides, and divide by pi, so that the r cubed is alone. Right, so we're just rearranging the formula. And then r cubed is not what we want r, so to get rid of a cube, remember we can take a cube root. And from there we can plug in our actual values, because we know the volume, we're given that. And this is one where you do need to be careful about entering it into your calculator, so do be careful with entering cube roots into your calculator. We've done this before. Make sure you know how to do it so that you can do it on a question like this. So this one should work out, if you're using your calculator correctly, to be 7.82 once we round it to 3 significant figures. And note that we have centimeters cubed. We take the cube root, cube and cube root cancel. We're left with just centimeters. Our next two questions, where we're looking at volume and surface area, are varying difficulties. The cylinder is actually pretty straightforward, but the second figure, which is a prism, is a little more complex. So we'll tackle that cylinder first. So we've got the radius, we've got the height. If we look at our formula for volume, and I strongly recommend pause here. Try and do the cylinder question on your own. So volume is pi r squared h. We know both r and h, so it's a matter of plugging them in. Then, when we're looking at the area, 2 pi r squared plus pi r h, again we can plug that all in, and we get a value of 114.6. And I think for both of those I said yes, express to the nearest tenth, so we went to the nearest tenth. So there's our cylinder. The prism, though, is more complex. So our volume is base times height, and our area is 2 base plus perimeter times height. But if we look at what we have there, we do not have the area of that base, and we do not have the perimeter of that base. In fact, we do not even know what those two, remember that lines say it's equals, so we don't know what those two equal sides are equal to. So we need to take this and break it up. So our triangle here is actually two right triangles when we cut it in half. So that's going to be 5 centimeters, that's going to be 5 centimeters, but we don't know the length of that value. So we'll do some calculations here for that prism so that we can get to those values. So that will be on the next video when we look at some of the more complex figures.